بسم الله الرحمن الرحيم. النهارده ان شاء الله هيكون اخر ليكتشر بالنسبه لنا Learning Outcome 7 Part 3 بالنسبه للفيرست سمستر، لكن انا يهمني ابدا معاكم بايه: قل اللهم مالك الملك تؤتي الملك من تشاء وتنزع الملك ممن تشاء وتعز من تشاء وتذل من تشاء بيدك الخير انك على كل شيء قدير. اسال الله العلي العظيم ان يكتب لكم دايما امر العزه، وان يوسد لكم الامور، وان يجعلكم دايما لصلاح هذه الامه ان شاء الله. Today inshallah we are going to talk about the pH curves and pH indicator, solubility product, and the problems on solubility product and the KW ionic product of the water. Firstly, we are going to talk about the pH curves. pH curves. Before talking about the pH curves, firstly let's talk about the type of indicator and the range from which the indicator work. So indicator, type, color in acidic medium, color in basic, medium, and the range of work, range. So if we start firstly by phenolphthalein, phenolphthalein, it's simple pH. Its type is a weak acid, and the color in acidic, it's colorless, but in the basic it will be red. Its range work from the 8.3 pH till 10.5. The second one we are going to talk about the methyl orange. It's weak base, and about the color it will be red in the acidic and the yellow in the basic medium. Its range start from 3.1 pH to 4.4. Litmus, it's about the weak base. Its work as a red in the acidic medium and the yellow or blue in the basic medium, and its range from 5 to 7 for the pH. One from the indicator, it's called the methyl orange, and the weak base else red, methyl red, not methyl orange, methyl red, and it's yellow in the basic, and it's range from 4.2 to 6.3. One from the indicator, it's called the universal, and we will find in the Zondel a table for the range of indicator. But when we work, I prefer to work in the phenolphthalein sometimes and the methyl orange. Now we are going to talk about the first one for the pH curves or titration curves. Firstly, we will start by the curve of the strong acid with the strong base, strong acid, and the strong base. So the titrant or the X curves, it will be titrant or NaOH, and on the y-axis we'll put the pH. In this time, firstly, we'll find the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, till 14. Let's assume that for this curve 1, 5, maybe 10, till 14. I think it's still 14. Okay. Firstly, we'll start from the one as the strong acid. We added the titrant till we reach the point is about 25 milli. When the 25 milli, we will find the completely change taking place till 10. Then after the 10, this is called the point of equilibrium or end point. What's meant by the end point? End point at which all the acid reacts or titrate by titrated with base. And then we'll find the value of the pH is increased else. The end point for this strong acid and strong base, it will be at 7. Okay? What is the medium, or what is the type of indicator can work between the 3, starting from the 3? This straight line is start from 3. Straight line start from 3 till we reach what? Till we reach the 10. It is the range at which endpoint work in it. So we'll find in this area suitable indicator to be work, maybe pH, litmus. Different type of indicator can work in this area for the strong acid and the strong base. NaOH 0.1 molar, 0.1 molar. Okay. First slide. Let's talk about what's happened if we react or use strong acid, strong base. Now we are going to talk about strong acid, weak base. Strong base, weak acid, or weak acid with a strong base. Weak acid and the weak base. Strong acid, NaOH 0.1 molar, the pH value. In this time, we'll find for the strong acid, it will start from the lower point. Then reaches the point of titrations. And the weak base, we'll find this is, I think, at 8.3. Then we'll find the value of the pH for the indicator. It will be less than higher value, like 14 or 12 or 10. It will be after the 10, it may be reach the, I think, 10. Okay. Yes. If we work for the strong base and the weak acid, for the weak acid, we'll find that we will find strong acid and weak, strong base and weak acid. Weak acid will start, I think, from 4. So we'll find the value of the pH, it will be 4. Then the end point. Then we will find it's taking the higher value when we're reaching for the base. Okay? Type. Weak acid, weak base. This is NaOH, pH value, NaOH, pH value. Firstly, you will find for the weak acid start from 4 and the end point, and weak base else end at 8 and 4. So we'll find the shape of the curve like this. In this range from 4 toward 8, it is the end point for this. Let's talk about the solubility product and Ksp. This is the second slide. Solubility product for any springly soluble ionic compound in the is the product of multiplication of concentration expressed in the mole per liter of its ions raised to its power number of the ion, which exists in equilibrium with the saturated solution. Solubility product is related to springly soluble salt, like when you will find a salt like AgCl. It forming to us Ag positive plus Cl negative, the aqueous and the aqueous and the solid. The common reactions are, in this case, it is the backward direction, not the forward and backward. We will find that the salt in this case are preferred to return the backward. Why? We are going to talk about the reason why the reactant in this case, or the equilibrium taking place or shifted backward, or the formation of the solid substance. Since this substance is springly soluble in the water, springly soluble in the water. What is the suitable conditions for forming PBT? Suitable conditions to form PBT. Multiplication of the ions of ions concentrations is greater than the value of the Ksp, with this taking place in the supersaturated solution. Supersaturated so in this case, no PBT formed. Or I mean PBT is formed in this case when the multiplication of ions concentration greater than the value of the Ksp. In this case we will find the PBT is formed. But if ions concentration equal Ksp, or ions concentration less than the value of the Ksp, in this case saturated solution, in this case unsaturated solution, so for overall of this, no PBT formed. No let's explain it. If the ions concentrations or the concentration of the product in this case greater than the value of the Ksp, so the dominate reactions or dominate side is formation of the PBT. If the concentrations of the ions, multiplication of the concentration of the ions greater than the value of the Ksp, in this case we'll find it is a supersaturated solution. Supersaturated solution, so we'll find one of the PBTs are formed on the solution. يعني انت بالعربي كده لما يكون عندك محلول مشبع, okay, the number of the ions dissolved is greater ions, so we'll find a PBT is formed. But if the concentration of the ions in this case less than the value of the Ksp, or equal the value of the Ksp in the case of saturated or unsaturated solution, we will find no PBT is a formed. We are going to talk about what is the idea of the Ksp, and all of you will be concentration in this part. Ksp problems. The idea of the problem in the Ksp may be giving to you concentration of ions. One of ion concentrations. Degree of ionization. Value of the Ksp. طب دي هنا ايه؟ It will be the given. He asked you about what? The given. Ask about. In this three cases, it's talking about the Ksp, but in this case, it's asking about ions concentrations. Right. Give you an example. Find Ksp value. If you know that. Silver sulfate, concentration of the silver 1 times 10 bar negative 3, and sulfate 1 times 10 bar negative 3. Second case, for barium chloride, find Ksp. If you know that, the concentration of chlorine equal 1 times 10 bar negative 3. Silver chloride, for silver chloride, the degree of ionization is 1 times 10 bar negative 5. Find Ksp. Silver or sodium phosphate. Sodium phosphate. Ksp equal 1 times 10 bar negative 4. Find ions concentrations. Firstly, write the equation Ag2SO4, solid substance. It will form to us Ag positive 2 Ag positive 1 plus SO4 negative 2. According to the salt, how can I determine the ions that produced from it? Firstly, Ag2SO4. Circle around the 2 and making the 2 in the front of Ag, the first one. Then cross side to other type or other part of the salt, but by negative sign, so we'll find it will be dissociated in 2 Ag positive 1 and SO4 negative 2. Okay, Ksp equal the concentration of the silver raised to its power 2 multiply SO4 negative 2 raised to the power 1, since the number of mole in this case is only 1. So it will be 1 times 10 power negative 3 power 2 multiply 1 times 10 power negative 3. Second idea, write the equation barium chloride BaCl2 giving to us barium chloride, giving to us, it is a solid substance, giving to us Pa positive 2 and 2Cl negative 1. According to this, we can write the barium chloride. This is 2. It will by the cross section toward the barium, giving Ba positive 2, and it will be in front of the chlorine, so it will be 2Cl, and the chlorine is monovalent, negative 1. Okay? Make the mole ratio between the chlorine and the barium according to the equation: 1 mole of ions giving the 2 moles of ions. Type. If we find the concentration of the chlorine, 1 times 10 power negative 3, what is the concentration of the barium? It will be, in this case, 0.5 times 10 power negative 4. So Ksp equal concentration of the barium multiply the concentration of chlorine raised to power negative 2 or power 2. It will be 1 times 10 for the barium, 0.5 times 10 power negative 4 multiply 1 times 10 power negative 3 power 2, and this is the value of the Ksp. The third idea, giving to you the degree of ionization. Concentration equal degree of ionization time is the number of moles, number of ions moles. So silver chloride AgCl dissociated, giving to us Ag positive, Cl negative. Concentration of Ag positive equal the number of moles of iron. It's only 1 mole of ions from the silver times degree of ionization, 1 times 10 power negative 5. Concentration of chlorine, number of moles from equation, we'll find only 1 mole times 1 times 10 power negative 5. Type. What's happening if we find the 2 moles or 3 moles? Yeah, 2 times L. Number of moles is 2. If we have in the 2, let's consider we have in the 2 from chlorine, so it will be 2 multiply the degree of ionization. Okay. Ksp in this case equal silver ion concentration multiply chlorine ion concentration. It will be 1 times 10 power negative 5 multiply 1 times 10 power negative 5. The last one, the last idea, it's giving to you the Ksp. Firstly, write the equation: sodium sulfate Na3PO4 giving to us 3 Na positive plus PO4 negative 3. Let's consume that when I have the X, 3 mole of X from sodium and 1 mole X from phosphate. In this time, Ksp equal concentration of the sodium ion power 3 multiply the concentration of phosphate. So it will be 3x power 3 multiply x. So the Ksp 1 times 10 power negative 4 equal 3 or 3 power 3 or what? 27
x power 3
x power 4. Let's modify this question to making it power 4 times x. X power 3 and this x power 1, so it will be 27 x power 4. We have the quadratic root, so in this case the value of the x equal quadratic root 27 over I think 1 times 10 1 times 10 power negative 4 over 27. Then let's assume that it will be maybe 3. The answer is 3. Returning back, the concentration of the sodium
هو بالسري.
Yes. Sodium equal 3x, so it will be 3 multiply x 3 equal 9, and the concentration of phosphate as the sodium. This is for the Ksp. Kw, or ionic product of water, ionic product of water. Let's assume that we have the water is ionized in the water. The value of the ionization is giving to us H3O plus OH negative. So we'll find, let's consider this water work as the acid. Its donor for the proton, it will be H3O, and still only OH negative. Is liquid and liquid, giving hydronium aqueous and aqueous. What is the value of the Kc? In this time we'll find the Kc, it's called the Kw. So it will be the concentration of the hydronium multiply the concentration of the hydroxyl, and we can neglect the concentration of liquid since it's a constant. In this time we'll find the 1 times 10 power negative 7 for the acid equal 1 times 10 power negative 7 for the base. So the Kw it's equal 1 times 10 power negative 14 for the acid and the base. It is the last thing in our content. Inshallah, see you soon in the next semester. Inshallah.
معلش ايه الاختلاف ما بينها ما بين بقى الكيسي طبيعي يعني ليه كده سميناها كي دبليو وما بقاش
Okay.
بس.
If we asking about the Kc, it means the concentration. If we told the Kb, it's called the pressure. If we told you that the Ka, it's for the acid. Kb, it is the equilibrium constant for the dissociation of base. Kw, it means the equilibrium dissociation for the water.
يعني هو كلهم ثابتين هو الثابت بتاع الرياكشن بس بيختلف على الاسيد.
Yes. Ksp for springly soluble salts or solubility product springly.
المفروض ده كنا نقوله.
Soluble salts. ده اللي احنا اتكلمنا عنه من شويه الKSP، الافكار بتاعت الKSP or solubility product. I think it is the last slide. Inshallah, see you soon in the next semester content. Inshallah.